Yeah. So good evening to all of you. Let me know my voice is audible today. Fine.
Yes, sir.
Yeah. Thank you. So today we are going to discuss about uh, first thing we are going to discuss about uh, introduction towards optimization. Introduction towards optimization, and later we are going to discuss about gradient descent optimization, gradient descent optimization technique or optimizer. Later we will do some exercises on Google Colab based on gradient descent optimization technique. So these three things we are going to discuss in today's class. So as I said in yesterday's class, just I want to revise once again. So if we want to learn machine learning, the main three key points in machine learning are: first one is machine model of the machine learning model, and second one is data. So one is the machine learning model or machine model architecture, similar to our human brain, and second part is data, based on which you are going to train the machine learning model. So the data will be changes from problem to problem. In our electrical perspective, suppose if we want to design a machine learning model to estimate the load, then you have to take the load data. Suppose if you want to estimate the market price, that means at what price power will be purchased by the utilities in the energy exchange, then you have to train the machine learning model based on price. So that means here the data is the market price. Similarly, suppose if you are working on wind forecasting, then your data will be wind speed, whatever it may be, what you want to predict, that will be the data for you. So data will be changes from problem to problem. But you can use the same machine learning model if you want. If you think that machine learning model will perform well for that application also, then you can use the same machine learning model. But the data will be changes from one model to the another model. So 1 minute. Yeah. Fine. Right. And third part is learning algorithm. So these three are the key aspects that we have to know if you want to learn machine learning. First one is the machine learning model or architecture, and second one is the data based on which you want to train the machine learning model, and third one is the learning algorithm. That means what is the step-by-step procedure, and what is the strategy, and what is the approach that machine learning model will use to learn based on the available data. As I said yesterday, if a kid is joining in a school, let us assume the kid is joining in a school, then his brain is like a machine learning model architecture. And suppose he is joining in the nursery, so definitely he starts with ABCD alphabets. Then that alphabets are the data, similar to data. And learning algorithm, that is depending upon the what approach that school is following, that is called learning algorithm. That will be changes from the school to school. So which strategy is good, that school will be shine more when compared to others. Fine. So I hope you understand the what is machine learning model, and what is the data, and what is the learning algorithm. So in the learning algorithm, that learning algorithm are designed based on the different type of the optimization techniques. So learning algorithm will be designed based on different type of the optimization techniques. So in this course we are going to discuss about different type of optimization techniques and how these optimization techniques will help a machine learning model to learn based on the available data. Fine. So in this course we are going to learn how optimization techniques will help machine learning model to learn based on the available data. Fine. So before going to different type of optimization techniques which are used, so are you able to see the screen? Are you able to see the
Yes, sir.
Yeah, thank you. So
Yes, sir.
yeah, thank you. So before going to discuss about various optimization techniques which are used in the machine learning, first of all we are going to discuss about the fundamentals. So we will discuss about some introduction about the optimization and some discussion about the simple gradient descent algorithm, and we will do some lab exercises based on the gradient descent algorithm. And from tomorrow we are going to discuss about one by one optimization technique and how it will help the machine learning model. Different type of machine learning models are available. I got some. Can you give an example for each case? ML model definitely. Yeah. So fine, right? So we are going to discuss about from the next class onwards we are going to discuss about the optimization techniques which help, how it will help to train the different type of machine learning models. So we have the different type of machine learning models like linear regression model, simple linear regression model, and multiple linear regression model, and we have polynomial regression model, and we have some descent trees, and we have random forest, and we have SVM, that are called support vector machines, and we have the artificial neural networks, and we have the convolutional neural networks, and we have the recurrent neural networks, and similarly so many LSTM, that are called long short term memory, and GRU, that is called as a gated recurrent unit. So many machine learning models are available. Fine. So however, the main goal of this course is how optimization techniques will help the machine learning model to learn based on the available data, right? So for that purpose I'm not concentrating on all these models, but I am concentrating on the only simple linear regression model. Same thing will be applicable for the remaining also. The procedure, the process will be same, but the mathematical relations and mathematical modeling will be changes. So actually if I want to demonstrate the optimization technique, how it will be helpful for the machine learning, then I have to choose one machine learning model. So I am choosing the simple linear regression machine learning model to demonstrate to you how optimization techniques will help to learn the machine learning model based on the available data. Fine. So actually the main goal of this course is the detailed discussion about the optimization techniques or optimization algorithms. That's why I'm more concentrating on these things, and we are going to discuss about stochastic gradient descent optimization technique and batch gradient optimization technique and mini batch gradient descent optimization technique, and similarly we are going to discuss about the momentum, and we are going to discuss about the Nastran accelerated gradient, and we are going to discuss about the ADA-grad, and we are going to discuss about the RMS prop, and last one we are going to discuss about the ADAM. So we are concentrating all these optimization techniques. So it is difficult to explain all those things with respect to all these machine learning models. And also, if you want to learn something, if you want to learn some optimization technique, or if you want to learn some algorithm, it is better to start with very simple model. If you want to learn some concept, that is what I take the inspiration from my professors. So if you want to learn something, then while understanding the concept, then we start with the small examples. Then once you are familiar with the concept, then you can go with the bigger one. That's why I am starting with a small simple linear regression model, and I am trying to use this simple linear regression model in all these aspects. Right? So before going to all these optimization algorithms, we will discuss about some introduction, some discussion about the what mean by the optimization, and later we will going to discuss about the gradient descent optimization technique. So first of all, what mean by the optimization? So what mean by the optimization? So optimization is nothing but process of finding the or process of maximizing or either maximizing or minimizing an objective. So the process of either maximizing or minimizing a particular objective, that process is called as a optimization. Either maximization or minimization of a particular objective, that is called as a optimization. For example, suppose if you take one industry, their objective is maximize their profit. If you take any industry, any organization, definitely, so their objective will be, there may be some other objectives, generally I am telling, so maximize their profit rate. So that is also one of the example for the optimization problem, maximization of the profit. That profit is the objective and we are going to maximize that profit, so that problem is called as a optimization problem. Similarly, the same company produces a product, but when the customer's point of view, he trying to minimize his expenses. If he went to a supermarket, his desire is to get the goods at minimum cost. So minimization of the expenses is his desire. So in this perspective, that is also called as an optimization problem. That means the maximization of a particular objective or minimization of some particular objective, that process is called as optimization. In this process, we are trying to identify some variables at which the given objective will be either maximum or minimum. Those variables are called as a decision variables or control variables. Every objective has some variables. Every objective function has some variables. Sorry. Fine. So I want to give one more time, give that statement one more time. That is called what mean by the object optimization. So optimization is nothing but the process of identifying the values of decision variables at which a particular objective function will be either maximum or minimum. Or we can call it as a optimization is the process of maximizing or minimizing an objective function. That objective function, the value of that objective function depending upon some variables, and those variables are called as the decision variables. Fine. So in an optimization problem, we are going to see three parameters. One is called objective function, another is called decision variables, and another one is called constraints. There are some constraints. Fine. So I will give one example, small example, then you can understand how it will be. So most of the optimization problems have these three parameters. The main and mandatory thing is objective function and corresponding decision variables. Fine. So every objective function has ML model example. Okay. So I hope every optimization problem has three parameters called objective function and decision variables and constraints. But the objective function and decision variables are the mandatory for any optimization problem, whereas the constraints are for some problems the constraints are exist, whereas some problems the constraints will not exist. Right. So what is the objective function? So I will give one example. I will share one example with you all. then we can easily understand. Are you able to see this screen, right? A problem, PPT. See, this is the example for the optimization problem. This is the example for the optimization problem which is in front of you on the screen. The problem is, consider a chocolate manufacturing company. Let's assume there is a chocolate manufacturing company that produces only two types of chocolates, A and B. Fine. So there is a chocolate company which produces the two types of chocolates, and the other the A and B. Let us assume. And to produce these both chocolates, what are the raw materials? What are the required things? Are milk and choco. Milk and choco. Fine. I think you understand it. There is a chocolate manufacturing company. They are producing two types of chocolates like A and B, and to produce chocolate A and chocolate B, they required two materials called milk and choco. Right. Now, to manufacture each unit of A, let us see, to manufacture each unit of A, that means 1 unit of A and 1 unit of B, the following quantities are required. So what is that? Each unit of A requires 1 unit of milk and 3 units of choco. Right? That means if you want to prepare 1 unit of type A chocolate, then it required 1 unit of milk and 3 units of choco. And if the company want to produce 1 unit of chocolate B, then it requires 1 unit of milk and 2 units of choco. And the milk and choco are the raw materials, and A and B are the type of chocolate, like dairy milk or something, what would Snickers, like that type. And what are the raw materials? Are milk and choco. So to prepare 1 unit of choco, it required 1 unit of milk and 3 units of choco. To prepare 1 unit of B type chocolate, it required 1 unit of milk and 2 units of choco. The company kitchen has total 5 units of milk and 12 units of choco. Company has 5 units of milk. They have the 5 units of milk and 12 units of choco. Total number of milk units are 5. Total number of choco units are 12. Next, on each sale, that means on the sale of A and on the sale of B, on each sale, the company makes profit of 6 rupees per unit of A, and 5 rupees on selling of unit B. That means if they sell 1 unit of A, they will get the 6 rupees profit. Sorry, right? So if they sell 1 unit of A, then the company will get the 6 rupees profit. If the company sell 1 unit of B type chocolate, then they will get the 5 rupees profit. So this is the optimization problem. Then why it is called an optimization problem? You have to go to the last statement. Now the company wants to maximize the profit. The company wants to maximize the profit. Then how many units of A and B should be it produce respectively? So finally the problem is, how many units of A and how many units of B that company have to manufacture so that they will achieve the maximum profit. So it is the example for the optimization problem. It is in the text format, because if client, suppose if some project is coming for you, then definitely the client will give the information orally or in the form of the text. Then as an engineer, what you have to do, you have to develop that problem which is available in the text information into the mathematical modeling. Right? So this is the example for the optimization problem. Why it is called as optimization problem? In this problem, I want to maximize the profit. So I want to maximize an objective. That objective is called as the profit of the chocolate company. So like this, in the text format, you will get the project. You will get that a client will provide the instructions or requirements in the form of the either orally or in the form of the text. Then if you are really working on this project, then you have to convert that text information into the mathematical modeling. It is optimization problem. For optimization problem, we have to convert that optimization problem, that text format, into the mathematical model. Then how we convert this one to the mathematical modeling? Now we will discuss. See friends, so we know now we get that we are going to maximize profit, right? We are going to maximize profit. So what are the anyone can tell by seeing this statement, this problem, how we can calculate the profit? How we can calculate the profit? Total profit the company will achieve. Let's assume that company, if the company manufacture X number of A units and Y number of B units, if the company produces X number of A units and Y number of B units, then what will be the profit? Then what will be the profit? This is a variable now. We need to find what is the value of X and what is the value of Y. That means how many number of A units and how many number of B units that company need to manufacture so that they will get the maximum profit. Let us do X number of A chocolates and Y number of B chocolates. If they are able to produce and manufacture, then we will get the maximum profit. Let us do. If that is the case, then what will be the profit? Suppose the company produces X number of A chocolates and Y number of B chocolates, then what will be the profit? Just by seeing this statement.
6x plus 5y.
Thank you. Yeah, it is because on 1 unit of A you are getting the 6 rupees profit, and 1 unit of B you are getting the 5 rupees profit. So if we are producing X and Y number of X number of chocolates and X number of A type chocolate and Y number of B type chocolate, then the profit will be 6x plus 5y. Now we are going to maximize this one. So this is called objective function. So our goal in this optimization problem is maximize 6x plus 5y, which is called as objective function. Now what are the decision variables? So decision variables means the variables which will decide the value of the objective function. The variables which will decide the value of the objective function, or on which values the objective function will be depends. So those are called as the decision variables. So in this example, what may be the decision variable? What are the decision variables? What are the decision variables in this problem?
X and Y.
Yeah, it is a
X and Y, sir.
Y. Good. It's X and Y. So this X and Y are called as a decision variables, and this is called as a objective function. Right? So this is good, and this is also included. Now we are discussing about the constants, right? So how we get the constants? See the problem here. Suppose if you want to manufacture 1 unit of A, it requires 1 unit of milk, and if you want to manufacture 1 unit of B, it requires 1 unit of milk, right? Now tell me, if the company trying to manufacture X number of A chocolates and Y number of B chocolates, then what are the total number of milk units are required? Milk units are required.
X plus y.
Yes, it is a X plus Y.
X into Y.
No, it's X plus Y. I will share the screen again. See, on each unit of A requires 1 unit of milk. On X units of A, it requires X units of milk. On each unit of B, it requires 1 unit of milk. On each unit of Y units of B, it requires Y units of milk. So total number of units of milk required on manufacturing the X number of A chocolates and Y number of B chocolates is X plus Y. So these number of milk units are required. These number of milk units are required. But see, in the problem if you observe, total number of milk units available in the kitchen of the company's kitchen, total number of milk units are available 5. 5 units of milk, 5 milk units are available. See here, 12 units of choco units are available. 12 choco units are available, 5 milk units are available. Now I want to do the constant. X plus Y must be less than or equal to 5. I think agree, right? Because the company has only 5 units of milk. So X plus Y must be less than or equal to 5. Right? Next, what is? Now go to the next statement. Each unit of A requires 3 units of Choco and each unit of B requires 2 units of Choco. Then tell me, if you want to manufacture X units of A, then it requires 3X units of Choco. If the company want to manufacture Y number of B type chocolates, then how many chocolate units are required? 2Y. I think you agree, right? It is a 1 for 3. For this one, it is a 2. If it is X, then it is a 3X. If it is a Y, it is a 2Y. Now it will be
2y.
3X plus 2Y must be less than or equal to total number of units
5.
of chocos are available. It's a
12 units.
12 units.
12x.
Yeah, it's a 12. Less than 3. Total number of milk units are available 12. So that the 3x plus 2y must be less than or equal to 12. And definitely the x and y is called as the number of A type chocolate and y is called as number of B type chocolate. That must be a real number, positive number, right? So that's why the boundary
Decision
values
variable,
are x and y must be greater than or equal to 0. Negative number of products are not manufacturing, right? So we can say 0 means, so don't produce this type of chocolate. If you will say 1 means, so you can produce 1 number of chocolate. It will not show minus 1 number of units, minus 1 number of chocolates. So it will never be a negative number, negative value. Now these are called as the constraints. Here we are taking the inequality sign, right? It's called as the inequality constraints. Where in some examples we have the equality sign also. Some constraints we have the equality sign also. Like 2x plus 3y equal to 10, like that. So if you are getting this type of constraint, it's called as a equality constraint, and these are called as a inequality constraint. So these all are called as the constraints. So these are third part in the optimization problem. So like that, if you got a problem, generally the problem comes in the form of the text format or in the orally. Suppose if I am a client, so then I will inform you. So Mr. X, so I have a chocolate company. I am going to manufacture this and this, and so these are the number of milk units are available, and these are the number of choco units are available. Like that, they may give some oral instructions or they may give some text information. Then if you want to find the solution as an engineer, you have to convert that into the mathematical modeling. So this is called as a mathematical modeling for the optimization problem. So your optimization problem and the mathematical modeling of the optimization problem, you have the 3 parameters. One is called as the objective function, another is the decision variables, and another the constraints. The constraints may be a equality constraint or inequality constraint. Fine. And based on so this optimization problem can be separated into 2 categories. One is called constrained optimization, another is called non-constrained optimization. Constrained optimization and non-constrained optimization. So constrained optimization means in your optimization problem, once you can transform into the mathematical modeling, in that mathematical modeling you are able to see objective function, decision variables, and the constraints. Maybe equality or inequality constraint. Then it is called as a constraint optimization. If only objective function is available along with the decision variables, that's why I am saying that objective function and decision variables are the mandatory. If only objective function is available, objective function and decision variables are available without any constraint, then it is called as a non-constraint optimization. Fine. And further, again, this constraint optimization can be split into 2 categories. One is called as a linear optimization problem or non-linear optimization problem. Similarly, non-constraint also we can segregate it into linear optimization or non-linear optimization. Right? So linear. So I think you can observe. So what mean by the constraint optimization? What is the non-constraint optimization? In both cases, the common thing is the objective function. In both constraint optimization and non-constraint optimization, the common thing is the objective function. Whereas in the constant optimization, you can see the constraints, but whereas the non-constant optimization, you are unable to see any constraints. But the object function is available in both constant optimization and non-constant optimization, right? So suppose either in the constant optimization or in the non-constant optimization, if your objective function is linear in terms of the decision variables, either in the constant optimization or in the non-constant optimization, if your objective function is linear in terms of the decision variables, then it is called as a linear optimization problem, linear constrained optimization problem. If it contains the constant, then it's called as a linear constraint. If not, linear non-constant. In simply saying, it is a linear optimization problem. So linear optimization problem is, in an optimization problem, you have an objective function. If that objective function is linear in terms of your decision variables, then it is called as a linear optimization problem. Now tell me, this example will comes under next thing. And what about the nonlinear optimization, either in the constraint or in the non-constraint? So nonlinear optimization means, in the nonlinear optimization problem, your objective function is nonlinear in terms of your decision variables. In terms of decision variables, your objective function will be in the nonlinear in nature. But where in the linear optimization, you are able to see objective function in the linear form in terms of the decision variables. Now tell me, based on this discussion, the problem which we discussed now, it comes under linear optimization or non-linear optimization. We discussed some optimization problem in the text format. Later, we converted that optimization problem into the mathematical modeling. Now I am asking, this problem will comes under linear optimization or in the non-linear optimization.
As it is having inequalities, it comes under non-linear, sir.
No. See, I want to repeat once again. Either in the constant optimization or in the non-constant optimization, if your objective function is linear in terms of the decision variables, then it comes under the linear optimization problem. If your objective function is linear relation in terms of the decision variables, then it is called as a linear optimization problem. If it is in the non-linear in terms of decision variables, then it is called as a non-linear optimization problem. So now the problem what we discussed now, you can see 6x plus 5y, there is a linear relation. There is no square term or cube term or exponential or sinusoidal. No non-linear parameters are there. It is a simple linear equation, right? It is a linear equation. So as your objective function is linear in terms of the decision variables x and y, the problem what we discussed here comes under linear optimization problem. And moreover, as it has a constraint, if you want to specifically tell, then it's called as a linear constrained optimization problem. Linear constrained optimization problem. Then what is the non-linear optimization problem? In the non-linear optimization problem, your objective function is like 3x cubed plus 5y squared plus 3 into e power z, like that. Here the decision variables are x and y and z, and I want to maximize this function. This is the objective function. I want to maximize this objective function. Then it is called as a non-linear optimization problem, because your objective function is non-linear relation in terms of the decision variables x, y and z. It is in the non-linear relation. As objective function is non-linear in the relation, so then it's called as a non-linear optimization problem. If in that optimization problem constants are available, then it's called as non-linear constraint optimization problem. If the constants are not available, it is non-constraint optimization problem. Hope you understand up to now, right? Now come to non-linear so this is called as the optimization problem. It is a mathematical modeling for the optimization problem. Either if you choose this one or if you take this one, so this is called as a mathematical modeling for the optimization problem or representation of the optimization problem in the mathematics, in mathematical modeling. right? So it is not a optimization technique. Just you are modeling, just you are mathematically model the optimization problem. That's it. Now, so once you model optimization problem mathematically, then you have to choose some technique, some algorithm to solve this problem. This is the problem only, not technique. This is the optimization problem only. So now to solve this optimization problem, you have to choose one type of technique, one type of algorithm. So in case of linear optimization problem, we can use simplex method and dual simplex method and interior point method. So like that, different algorithms or different optimization techniques are available in online or in the literature to solve linear optimization problem. So these interior point method, simplex method, dual simplex method, all are called as the linear optimization techniques. It is called the linear optimization techniques. So these optimization techniques will help us to solve optimization problem. So solving the optimization problem means identifying the decision variables at which your objective function will be either maximum or will be minimum. That is depending upon your problem, right? In our case, we are going to maximize our profit. In some other case, there may be some example like minimization of the cost. Alright. If you go with the economic load dispatch, so that is in electrical terms I'm telling, some may not understand. If you go with the economic load dispatch problem, that is also a optimization problem. You have a objective function that is called the fuel cost and you have some constraints. So that comes under the optimization problem. Not okay. Now suppose now tell me if we consider economic load dispatch problem. If we consider economic load dispatch problem, let's assume we have a 3 generation units and fuel cost function of each generation unit will be in the form of AP square plus BP plus C. That means A1 P1 square plus B1 P1 plus C1, A2 P2 square plus B2 P2 plus C2, A3 P3 square plus P3 P3 plus C3. That are the fuel cost functions. Now if you are going to solve the economic load dispatch problem for these 3 generation units, now tell me this economic load dispatch problem will comes under linear optimization problem or non-linear optimization problem. Economic load dispatch problem will comes under
Non-linear, sir.
Yes, it is a non-linear optimization.
Square is there, right?
Yes. So it will because your fuel cost, that is why you have to minimize your total cost of generation, right? So where the cost of generation depending upon your fuel cost. That is the AP square plus BP plus C. The square terms are available. That are non-linear in nature. So it's called comes under the non-linear optimization problem. So here in case of the linear optimization problem, we are going to discuss about the these are interior point simplex method and dual simplex method. All are called as the optimization techniques which are used to solve the linear optimization problem. Similarly, to solve non-linear optimization technique, we are using gradient descent optimization algorithm. Similar to interior point simplex method, dual simplex method, which are the optimization techniques which are used to solve the your linear optimization problem. In the same way, we are using gradient descent algorithm or optimization technique to solve the non-linear optimization problems. Right? Moreover, if you come to the machine learning perspective, so in the machine learning, you are able to see non-constrained, non-linear optimization problem. In machine learning, we have a non-constrained and non-linear optimization problem. Why it is called non-linear and non-constrained optimization problem? Why it is called a non-linear optimization problem in machine learning? So we will came to know in the tomorrow's class. Why I am telling it the non-linear optimization problem. So just to demonstrate give some introduction about the optimization technique, I have given the different type of optimization problems, and also I am explaining this linear optimization problem. But moreover, this linear optimization problem will not come into our machine learning perspective. In the machine learning, we are going to use the non-linear optimization problem. So then again, to solve non-linear optimization problem that exists in machine learning, we are using the gradient descent optimization. Gradient descent optimization. Fine, I hope you understand the complete introduction of this gradient descent optimization. Sorry, introduction about the optimization problem, optimization techniques. Now we are going to move completely towards the non-linear optimization and how we are able to solve the non-linear optimization using the gradient descent algorithm. Gradient descent algorithm. Fine. Now, yeah. So, see friends, let's assume f of x is an objective function. Let's assume f of x is an objective function and x is a decision variable. That means the value of this objective function f of x, that is depending upon the decision variable called x. Now we are going to discuss about the non-linear optimization problem and how we are using the gradient descent approach to solve the non-linear optimization problem. So as we are discussing about the non-linear optimization problem, so definitely f of x is non-linear in terms of your decision variable x. F of x is non-linear in terms of your decision variable x. Right? So, fine. Right? 1 minute. Yeah, fine. Done. Okay. I will erase this. Right. Yeah. So this is f of x. Right. So as the f of x, which is a non-linear in terms of the variable x. So non-linear means, let's assume I want to take a function f of x equal to x square plus 5. F of x equal to x square plus 5. Right. So when x equal to 0, then f of x value equal to 5 somewhere here. Let's assume somewhere here. When x equal to 0, f of x that's equal to 5 somewhere here. When x equal to 1 square plus 5 that's equal to 6. That means when x equal to 1, so that may be the point will be here. When x equal to 2, then 2 square plus 4 9, so somewhere here. Like similarly, if you are going for -1, if you are going for -2, if you take -1 here, -1 whole square plus 5 that's equal to 6 and again comes here, and -2 whole square plus 5 9 that comes here. So now it's called as a convex function. Now it's called as a convex function. Right? So why it is called as the non-linear optimization? Because my objective function f of x is non-linear in nature. You can see it's not a linear curve, it is a non-linear curve. It is a non-linear curve and it is also simply called as a convex function. Convex function is which has only one bottom peak point or one optimum point, one minimum point. Global minimum and local minimum will be same in case of the convex function. That means it is a non-linear but not highly non-linear. It is a non-linear but not highly non-linear. So we will move slowly. Fine. So I think you can agree. So f of x is a non-linear. So f of x is a non-linear objective function. So it will be like a parabola. It is a parabola, right? Now my problem is, so now I want to minimize this function. I want to minimize this function f of x. Minimize this function f of x means, so the process of identifying the decision variable value at which the function f of x will be minimum. At which the function f of x will be minimum. Right? So definitely friends, I agree. I think most of your mind that thing is fluctuating. That is, we know when x equal to 0, function will be minimum. We know about that one, right? but I am taking this very small example for the demonstration purpose. You can apply same thing for the other solve, right? Fine. I think you agree, right? So this is a nonlinear optimization problem because your object function is nonlinear with respect to the decision variable, with respect to the decision variable x, with respect to the decision variable x. Fine. Okay, great. Now up to here. Now to solve this nonlinear optimization problem, I want to use gradient descent algorithm or gradient descent optimization algorithm or gradient descent optimization technique I want to use. So before going to how gradient descent optimization algorithm will work, first I want to discuss some more small mathematics, what we discussed, what we know, what we learn in the school level, right? So if there is a line like this, so that line can be represented as if it is a y and it is a x, and then y can be represented as y equal to mx plus c, right? So y is nothing but, or we can write this y is equal to function of x, f of x, it is a function of x. So I can write f of x equal to mx plus c. So this is the line equation, f of x equal to mx plus c. Now if you want to find slope of this line, or gradient of this line, what is the slope of this line? That is the m, right? So if you want to find the slope of this line m, then what you have to do? You have to differentiate your function with respect to x. You have to differentiate this function with respect to x, then it will be m, right? That means if you have a function with respect to some variable, and if you want to calculate the slope or gradient, then you have to differentiate that function with respect to the variable, then it will give the slope. That's the one thing you have to remember, right? That means if you want to find the slope of a function at a point, then you have to differentiate that function with respect to the decision variable. If you want to calculate the gradient of a function with respect to the decision variable, then you have to differentiate that function with respect to the decision variable. The gradient will represent the slope at that particular point. I think you can agree here, right? So if you want to find the slope of a equation, slope of a function, then you have to differentiate that function with respect to the decision variable if you want to find the slope there. Second thing you have to agree. And one more thing, that is, let's assume again I am taking the function f of x and this is x, and your function is, the function f of x is parallel to your decision variable x. It is parallel to the decision variable axis. Then what will be the slope here? Let us assume this is a 2, let us assume. Then f of x equal to 2. If you want to find the slope of this equation, then you have to do dou f by dou x, that's equal to 0, right? So from this discussion you can understand one thing is, if you want to calculate the gradient or slope of an equation, then you have to differentiate the function which represent that line or curve, whatever it may be, with respect to the decision variable. It will give the slope or gradient. Second thing, if the function is varying parallel to your decision variable, if you draw a curve between your function and decision variable, it is parallel to your, if that line is parallel to your decision variable, then the slope will be 0. Hope you understand these three concepts. Then we will move to the gradient descent optimization algorithm. So gradient descent optimization technique now we will discuss. Fine. So how it will work, I will tell you now. Right. So this is the function f of x, objective function f of x, and this is the x now. Right? Good. So let's assume the object function f of x is a pure convex function. Let's assume it is a pure convex function. Now, how it will work is, gradient descent algorithm, how it will work is, in the search space of x, because we want to identify the value of x at which your objective will be minimum. So your objective function f of x equal to x square plus 5. Now I want to identify the value of x at which your objective function will be minimum. So this complete axis is called a search space that may be varying from minus infinity to the plus infinity. So that is, if you think x is the decision variable, its space is from minus infinity to the plus infinity. Somewhere else that optimum point will be available. That optimum point we know. I am taking small example, that's why we know. If it is a complex one, we don't know. We have to find that optimum point. So we know that optimum point is here is this one. Fine. Now see. So how the gradient descent optimization algorithm will work, I will tell now. In the gradient descent optimization algorithm, the first step what you have to do is you have to choose randomly the value of x in the search space. In the search space, you have to find, you have to randomly choose some initial point. You have to choose some initial point in the search space. Let's assume the point, randomly chosen point equal to, let's assume that's equal to x equal to 5, let's assume. Randomly generating one value. From that point I am start searching. Right? For example, simple example, suppose there is some health worker who is working in an hospital, and the hospital superintendent told that health worker that Mr. X go to some street and search whether there is any COVID patients or not. So definitely you have to start from one point, right? You have to randomly choose one house and you have to start testing from that house. Randomly you have to choose some point, right? But where that patient is there, we don't know until that search is completed. Like that, in the gradient descent algorithm also, we are starting with the random point. Let's assume that randomly generated initial point x equal to 5. Let's assume that's the x equal to 5. This is a random point. Right? Now what we have to do is, at that point you have to calculate the slope or gradient, slope of the function or gradient of the objective function with respect to the decision variable. You have to find the slope. It's called a tangent, right? Slope is nothing but a tangent. So you have to find the slope of at that point. At that point you have to find the slope or gradient. That is called, you have to find dou f by dou x at x equal to 5. At x equal to 5. Suppose, so if it is here, it is called as a positive slope. It's called as a positive slope. Right? So if the slope is positive, then you have to update your position such that the point will move toward the negative slope. Negative slope means, suppose, let's assume the initial point x equal to minus 5. Let's assume initial point x equal to minus 5 and somewhere else here. X equal to minus 5 means somewhere else. Let's assume it's the minus 5. Now if it is the initial point x equal to minus 5, then you have to find the gradient at that point, dou f by dou x at x equal to minus 5. So this will be the gradient or slope of that equation here, like that. So this is called as a negative slope. Here it is called as negative slope. Right? That means, so what is, but actually if it is a convex function, your optimum point will be at the bottom. Your optimum point will be bottom. At the bottom, what will be the slope? At the bottom, what will be the slope? If you draw a tangent there, the tangent will be definitely parallel to your decision variable axis. It is parallel to your decision variable axis. Now, what will be the slope at this point, or what is the gradient at this point? What is the slope at this point, or my question is, what will be the slope or gradient at optimum position of a convex objective function? If you choose a convex objective function, then what will be the slope at the optimum point? What will be the slope at the optimum point? Please, everyone respond. Maybe what will be the optimum point? So that's why I'm telling in the previous case, that is, if f of x is parallel to the destined variable, then we can call f of x equal to 2 and dou A by dou x gradient or slope that's equal to 0. So at the optimum point, at the minimum point, that gradient will be, the slope will be, or the line which is drawn here, tangent is nothing but the slope will be parallel to your destined variable axis. So here your slope or gradient is equal to 0. The point where your slope will be equal to 0, that is the optimum point. So because of that reason only, if you try to remember, maybe in our school education we learn some mathematics like or sir give f of x equal to x square plus 5x plus something and find the minimum value or maximum value. Then we are calculating the first derivative of this one and we are making it equal to 0 and we are finding the x values. And we said that is the minimum point or maximum point. Why we are taking a first derivative of that function and making it equal to 0? Because of that reason. Dou A by dou x equal to 0. Because of that reason, we are taking the first derivative as a 0. First derivative as 0. So, what I want to tell you is, if you choose x equal to 5, you are getting the positive slope. If your random initial value is a minus 5, then you are getting the negative slope. But at the optimum point, your slope will be 0. At the optimum point, your slope will be 0. So, if you understand these things, let's assume your initial point x equal to 5. Your initial point is x equal to 5. This is x equal to 5. So here you are calculating a gradient and that gradient is positive, greater than 0. Then what a gradient descent algorithm will do is, it try to update this point, moves toward the negative slope. Where the negative slopes are available? The negative slopes are available here. Then what is happening is, then the gradient descent algorithm try to move this point toward the negative slope like this. And from here to here. And from here to here, once it reaches this point where the slope equal to 0, then it will be stopped here because it is the optimal point. This is the optimal point. Understood? So suppose if the initial point gives the positive slope, then the gradient descent algorithm will try to move that point toward the negative slope side. When slowly it is moving toward the negative slope side, finally it lands at the 0 slope point where we can find the minimum value. That's what we require. Right? Suppose, let's assume, if your initial point is x equal to minus 5. Suppose if your initial point is x equal to minus 5. Then that point will be here, initial point will be here where it is a negative slope. So when it is a negative slope, then what the gradient descent algorithm will do is, the gradient descent algorithm will try to move this point toward the positive slope side. The positive slope is available here, right? So it is trying to move toward the positive slope side, so that point will be updating like this and finally landed at that 0 slope point. That is called the minimum point. That means if the initial point will be in this genre or the initial point is in this genre, and finally as the iterations are progressed, then it will be landed in the optimal point where the slope equal to 0. So I hope you understand, right? Now we will discuss about how that gradient descent algorithm will work and how it will trace the optimal point in the sketch space. So I am explaining with some graphical visualization, right? So next thing is, now we are going to discuss about the step-by-step procedure for the gradient descent optimization algorithm by taking the small example x square equal to 5, right? So see friends, you have to observe here is, so the initial point gives your slope is positive, then the gradient optimizer try to move that point toward the negative slope side. If the slope is negative, then it is trying to move toward the positive slope side. So this will be done until it reaches this bottom point. Toward the bottom point. Right? Now I want to tell you the step-by-step algorithm of the gradient descent optimization, and later we will do some numerical calculation. Later we will apply for the lab. We are going to the lab. Now let us assume my optimization problem is minimization of f of x equal to x square plus 5. Friends, I am again telling you, so no need to do this complex iterative process to find this to solve this optimization problem. But I am taking this small optimization problem to help you how the gradient descent algorithm will work. So what I told, so in the first step, step 1, what you have to do is you have to randomly initialize descent variable value. Here descent variable is x, right? So you have to randomly initialize the descent variable value. That's x equal to, let us assume x equal to 2. Let us assume x equal to 2. Randomly, because in a such space we have to start from one point. So that point we have to choose randomly. From that point we from this point we start searching, and finally we reach the value of the x at which your objective function will be minimum. Right? Okay. Now what the second step? So second step is you have to calculate the gradient of a objective function, with respect to the descent variable at the given point. So you have to find the gradient. That's called dou f by dou x at x equal to, what the available point is there? Here the value equal to 2, x equal to 2. So what is the dou f by dou x? That's equal to 2x, that's equal to 4. So this is the gradient, that's equal to 4 now. So second step is you have to find the gradient or slope of object function with respect to the descent variable at the point where we started. Now step 3. In step 3 what we have to do is, and set here you have to set iteration. So let us assume it's the step 2. It is the iteration count equal to 1. Let us assume it's the step 3 and it's the step 4. And you have to initialize the maximum number of iterations you want to run this algorithm. That is called number of epochs. Let us assume it is 100. Let us assume number of epochs I want to run this gradient descent algorithm to find that point, that's equal to 100. Fine. So we are randomly initializing a value x equal to 2 and we are calculating the gradient at that point, that's equal to 4. In step 4 what we are doing is we are trying to identify how much step that point will be taken toward the negative slope side. Why you are taking the negative or positive, next we will discuss. So next step is how much step that point will be updated, how much step that point will be taken to move to the next position. So I will tell in this diagram here. So now you have to find how much step, it is the initial point x equal to 2, let us assume, then how much step that will be taken from here to here. So that we have to find. So if you find the step length, then we can update this point easily from here. If you are able to find the step length, then we can update the point x from here to here by adding this step value to this initial point. So now what are the next task, what we are doing in the step 4 is how much step length that we have to take, how much length that a point will be moved from initial point to next one. That step length we have to find. So how you find the step length? So the step length can be found by using the formula that's called delta x, that's equal to minus dou f by dou x at x equal to 2. So that step length, how much step length you are taken, that is depending upon your gradient. So dou by dou x at x equal to 2. Then anyone can tell why I am taking the negative sign here? Why I am taking the negative sign here?
Because slope is positive.
Why?
Because slope is positive.
Right. See, initially when we are at the x equal to 2 point, then the positive slope is there. Now I want to update your position of the new point toward the negative slope side. So if it is a positive, then we have to move toward the negative slope side. If it is negative, then we have to move on the positive slope side. That's why I am taking negative sign here. right? I think you understood why I'm taking negative. That means your step length makes your point moves towards the negative slope if it is in the positive slope side, or your point will move toward the positive slope if it is the negative slope side. So to do that one, I am taking the negative sign here. And one more parameter we are using in the gradient descent algorithm, that is called as eta. That is called as learning rate. Learning rate. Eta is called as a learning rate. That learning rate will decide how much step length that point will move, how much distance that point will move from one point to the other point. So I will draw this diagram again here. So your point will be moving like this, right? So how much step length it will take, that is depending upon your learning rate. That is depending upon your learning rate. So here learning rate we are considered as a hyperparameter. Learning rate is considered as a hyperparameter. So that we have to choose the value between the 0 and 1. The learning rate eta value will be between the 0 and 1. Right? So that is the hyperparameter. We have to choose proper hyperparameter value. You have to choose proper eta value. Right? If it is a complex problem, it will have the impact on it. For small problem like that, it's not an issue. We can choose some value between 0 to 1, it will reach us. Then what is the impact of learning rate on the finding the solution of a optimization problem is, suppose if the initial point is here, suppose if you are taking the learning rate is very high, like 0.99 like that, if you take the learning rate high, 0.9 something like that, then what is doing is, it taking a bigger step like this, and from here to here. Now it is not landed at the zero slope is here, right? It is not landed at here. Now because of the high step length, then it will move from here to here. Now what happened? It skipped the optimal point. Then once the point is in the negative slope side, then what it is doing now? As it is the negative slope side, then it is trying to move toward the positive slope side, then it takes the step from here to here. And from here to here again. And as it is a positive, then it is coming back to negative. And negative, it is coming back to here. Because of the large step size. If you choose the large learning rate, there may be a problem of oscillation of the solution around your optimal point. This is the optimal point. So there may be an oscillation of your solution around this optimal point if you choose the large learning rate. Generally, we thought that trying to use large learning rate, okay, we will discuss next. So I hope you understand, right? Second thing, suppose if you choose the learning rate is small, then what happened? If the initial point is here, then it will move from here to here, 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 here to here. So if you choose a small learning rate, the possibility of escape of the local point will be very, very minimum. Whereas if you choose the learning rate very high, there is a possibility of skipping from the optimal point, and there is a possibility of oscillations. This criteria is called as overshoot under. It's called as overshoot. Overshoot means it is jumping from one point to the another point and skipping the optimal point here. It is skipping from this point to this point, and it is skipping this one. It's called as overshoot. That overshoot problem will occur if you choose large learning rate. There is maybe. But if you choose a small learning rate like 0.0001 or 001, then your step length will be very, very small and slowly reaches to the possibility of overshoot problem, and possibility of skipping the local minimum point will be very, very less in case if you choose the learning rate is very small. But what the problem here is, as it takes a very, very small step length, it will take more time to converge, because it will take more number of iterations. One iteration from here to here, second iteration from here to here, 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 here. Take the more number of iterations to reach to the optimal point. So it may take the more time to converge. It will take more time to converge. But in case of the large learning rate, it takes the very less time to converge, but the possibility is overshoot. There may be a skipping of the optimal point, there may be a oscillations. And here the problem is it takes the more time. The possibility of skipping this optimal point is very less, but it takes the more time. So that is the significant impact of the learning rate on your optimization technique, finding the solution. So for example, in this case, I am taking some 0.1 or 0.01. So that's why generally most of the algorithms we are using the self-adaptive learning rate. The learning rate will be adapted based on where it will be. So we will discuss later. Fine. So in the step 4, what you are doing, you have to find the step length, how much jump that point will be take from one initial value to the next value. That is depending upon the learning rate eta and the gradient. So we are calculating like this. In step 5, what we are doing here is, we have to update your point. That's equal to x plus delta x. So this x is the initial point, 2, delta x is the step length. So what will be the delta x here? Minus, if you choose the learning rate equal to 0.1, so minus 0.1 into dou f by dou x at 2, that's equal to 4. That's equal to minus 0.4. That minus 0.4. Now what is the new value of x? That's equal to initial previous value of x equal to 2, right? So 2, delta x equal to minus 4, that's equal to 0.4. Now it is equal to 1.6. That means it is a function when you are at the 2, now it is moving from 2 to 1.6. That means it's slowly moving towards your optimal point. Slowly moving towards your optimal point. It is a 2 and it is a 1.6. It is slowly moving towards your optimum point. Right? Slowly moving towards your optimum point. I think you agree here, right? So that's C. So it is actually we know our solution equal to 0, right? We know our solution equal to 0. Right? That means you can tell, you can say the actual minimum value of f, actual value, that's equal to 0. Actual value equal to 0. But actually what is the current value? Not actual value. Actual value equal to at what value of x your function will be minimum. So that's equal to, at x equal to 0 your function will be minimum, right? That's equal to 0 square plus 5, that's equal to 5. So that is the minimum value, right? But what happened here is, now step 6, let us assume. Now compute your function at here. You compute your function here, right? Then what you have to do, there are different ways. I am telling one procedure. So you have to find function at the current point. So what is the value here? 1.6 whole square plus 5. You are getting something, right? So this is what is the current value of the function, but actual value of the function equal to 5. The difference between these two are called as the error. So this algorithm will run until you are getting this difference between the actual value 0.1 and final value, that is called this function value, will be almost equal to some 0.001, like that, very small. That is the one aspect of taking the convergence criteria. Finding the difference between the actual value and current value. If the difference between these two almost equal to 0, then we can stop the iterative algorithm. That is the one aspect. That aspect will be applicable only if we know the actual output. That means actually what is the minimum value of the function. If we know minimum value of the function, then we can go with this approach, convergence approach. So what is convergence approach? We have to know the actual minimum value, but you have to identify the value, and difference between these two you have to calculate. If the difference between these two almost equal to 0, that means actual minimum value and current value almost equal, difference between these two almost equal to 0, then we can stop iterative algorithm. This will be applicable only actual value is available for you. If the actual value is not available for you, then what we have to do? We are using the convergence criteria in terms of the number of epochs. Number of epochs means, so I will rough it again. Right. Now function is updated, right? So I will rough all those things. So in step 6, what we have to do is, here setting iter equal to 1, right? Now we have to update iteration. Set iter equal to iter plus 1. That means you are updating your iteration. Once you are updating your iteration, in step 7, you have to compare. If your iteration is less than or equal to number of epochs what you decided initially. That means you want to run this iterative algorithm by the 100 iterations. So you have to check this one. If the iteration count is less than or equal to number of epochs or not. If this condition is satisfied, that means the number of iteration count, the iteration count, current iteration count is less than the maximum number of epochs you have decided. Then what we have to do? Again go to step 3. If this is satisfied, then go to step 3. Else, otherwise, go to next step. I hope you understand, right? Let's assume I want to run this iterative algorithm for the 100 iterations. Now, if the current iteration count equal to 90, which is less than the 100, then what we have to do? Go to, suppose in this case current iteration count is 2, right? So 2 is less than or equal to 100, so it is satisfied. Then go to step 3. Now step 3 what you have to do? Again you have to calculate the gradient at x equal to, anyone can tell? In the second iteration, we are calculating the gradient at x equal to, I am repeating once again. Initial point is x equal to 2. First iteration I am explaining. Initial point x equal to 2. Iteration count equal to 1. And we are calculating the gradient at x equal to 2. And we are getting the gradient 4. Now we are finding the step length based on the learning rate and the gradient. We are getting the minus 4. Now I am updating my point, that my new point equal to x equal to x plus delta 6.
X is equal to 1.
Yes, yes. So now it is x equal to x plus delta 6. Delta x, so it is a 1.6. Now iter equal to iter plus 1. There is a 2. Iteration count is 2. Now step 7. As iteration count true, it is less than or equal to 100. So it is satisfied. Then we have to go to step 3. Now step 3 what we are doing? Again we are calculating the gradient of a function with respect to the decimal variable. At 2.
X equal to 1.6.
Yes. Now we are calculating it x equal to 1.6. And do the step 4 and step 5. You have to repeat again. So this process will be repeated until you get the iteration count is greater than number of epochs. Suppose if your iteration count is 101, let us assume, because we are updating right here. Suppose if you are getting the iteration count is 101, then here is 101 less than or equal to 100. It is not satisfied, right? Then else condition, go to next step. In the next step what you have to do is just print the output values. That means you are converging in terms of the maximum number of iterations. Then you have to print your output. Output means what is the value of x and what is the value of f of x. That's it. Fine. I hope you understand. I am explaining the gradient descent algorithm with some numerical example. It is simple exercise and a simple algorithm. And why we are taking all the things, and also explain with some visualization, with some graphical representations. So you have to remember this concept, because in rest of all 7 to 8 algorithms, almost similar exercises we are doing. Same type of information we are taking, but slight modification, especially in step 4. Especially in step 4, while calculating your step length, we are taking a small variation. That variation changes from the optimizer to optimizer. But the heart of any learning algorithm of a machine learning will be this thing only. Actually, we didn't learn anything new. These all are from our basic school level or maybe intermediate mathematics. But these are hard for the machine learning. So I hope you understand the numerical example and the step-by-step procedure for gradient descent optimization algorithm. Now we will do some lab exercises, and so later we will close the session. Fine. So actually I shared the Google Colab link for gradient descent optimization algorithm. So just follow me today. Later you can try yourself. If you have any doubt, you can call me. I will explain again. Fine. Now we will do the lab exercises. So now I will remove my Wacom and everything.
Sir, small doubt, sir.
Vijay sir?
Sir,
Okay.
how we will take learning rate, sir?
That is the hyperparameter, sir. So you have to choose some random value.
Some random value between 0 to 1.
Some random value between 0 to 1 you have to choose. Suppose if you think your algorithm is not working properly, then you have to tune the learning rate. You have to
Okay.
tune the learning rate slowly. So sometimes there is some say I will give one suggestion. I will tell later after lab. I will tell later. Otherwise tomorrow I will discuss how will
Okay.
that tune the learning rate also.
Okay.
Now I will want to share our Google Colab notebook. Are you able to see here, right? Are you able to see here, right?
Yes, sir.
Yeah. So this is the Google Colab book. I already shared with you. So maybe most of the people have only one device. If you have the two devices, then you follow me in one device and you can do your exercise on your another device. Otherwise, just follow and later you can exercise it. Now see. Find the minimum value of f of x that's equal to x square plus 5. Right? So these things already we discussed. What are they available here? This is a numerical calculation already explained for you. Right? Now see, come to the code now. We will discuss on the code. So fine, please listen. I am developing this code in Python and we are running in the Google Colab. This is the first line. So in Python we have different type of libraries are available. So one of that library is called random. So you have to import a random library in order to generate a random number. In order to generate a random number. Random library is available in the Python to generate a random number. Now my question is, where we require this random number? ఎక్కడ మనకు అవసరం ఉంటుందాం? ఎందుకు ఈ ర్యాండమ్ ఫంక్షన్ ర్యాండమ్ నెంబర్ జనరేట్ చేయడం కోసము యూజ్ చేస్తామని చెప్పాను కదా. వేర్ వీ రిక్వైర్ దిస్ ర్యాండమ్ నెంబర్ ఇన్ ఆ గ్రేడియంట్ డీసెంట్ ఆల్గరిథం?
To select starting
Initial value, step 1.
Yes. So because in the initial stage we are randomly choosing some initial point, right? So to choose that initial point randomly, I am using rand library. So I am importing rand library, right? Now I am importing math library to do some mathematical to use some mathematical functions. So math library as empty, like empty is called alias name, because you suppose if you don't use this as empty, then you can use math in rest of the code, or you can use empty instead of math in the rest of the code. That's the alias name, just alias name. So import math as empty. Now x equal to random dot uniform minus 10 comma 10. That means what I am doing here is I am randomly generating one value from minus 10 to 10 and assign to the variable x as the initial point. I am randomly generating a value from minus 10 to 10 and assigning that value to the x. Just a minute here, please give me time. 1 minute. Yes, charging is over. That's right. Sorry for the delay. So I am generating a random number between minus 10 to 10. So that is the initial point for x, and eta equal to 0.01. That is called learning rate. Eta equal to 0.01. That is called learning rate. And maximum number of iterations I am choosing as a 10,000. 10,000 iterations. I want to run that gradient descent algorithm. Fine. So I think this one, there is no issue with these 5 lines of code, right? Next thing, in every iteration, one thing we are doing, you have to observe, that is we are calculating the gradient. Right? Now what is the gradient of this function? What is the gradient of this function? F of x equal to x squared plus 5. What is the gradient of the function with respect to x? So gradient of the function with respect to x. That's a dou f by dou x, that's equal to 2x, right? So gradient equal to 2x. The value will be changes with respect to x. If the x is changes, then the value of the gradient also changes. So that gradient I am using calculating as a function. See, if you try to remember your MATLAB, maybe some of the people have do some exercise on the MATLAB. In MATLAB, we are using function, name of the function, function and variables equal to name of the function, and we are calling the input parameters, right? So in the Python, we are creating the function like this. So if you want to create a function, you have to start with def. So def means we are defining a function, and you have to give some name to your function. You have to give some name to your function, and you have to pass some inputs. You have to pass the inputs. So I am passing the input x. So what this function will return? It will return 2x. That is the gradient. It return a function, return a value 2x. 2x is called as a gradient because f of x equal to x square plus 5. So dou f by dou x equal to 2 into x. The 2x value will be written. So this is the f function which is used to find the gradient of that function. Gradient of the objective function f of x equal to x square plus 5. I think this is also fine, right? Now, for now how we use the for loop, how we create a for loop in the Python, now we will discuss here. Because I want to run this algorithm over multiple iterations, right? So for that, to run the loop for the multiple iterations, I am using the for loop here. So how we define a for loop in Python is for variable in range of max iterations. That means range of max iteration means, suppose friends, I want to tell one thing. Try to remember your MATLAB or C. C is somewhat different, right? Come to MATLAB. How we write in the MATLAB? For I equal to 1:10. Then it will run from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up to 10, right? Similarly, this is the syntax for the for loop in the Python. Iter. For iter is a variable. You can use I, A, B, C, whatever it may be. I am using iter as a variable. Iter in. So these two values will not change. For in, these are the common, but you can change this variable name. For iter in range max iter. So what it will give is, if you write range 2, if you write range of 2, then it will give 0, 1. If you write range of 3, then it will give 0, 1, 2. If you write range of 4, then it will give 0, 1, 2, 3. So if you are writing range of max iter means 10,000, then it will give 0, 1, 2, 3, 4, 5 up to 999. Then what it will take? First iter take 0 and you will run algorithm. Take iter equal to 1, iter equal to 2, iter equal to 3, iter equal to 999. Up to that it will be run. So simply in our MATLAB we can treat this one as a for iter equal to 0:999. It is similar to that one, right? So like if condition, you have to terminate the first statement also with this colon. Next, what I am doing here, you are able to see here, right? What I am doing, see here, delta x, del x is a variable, that's equal to minus eta gradient of x. So I think you understand it. What are you doing here? What we are doing here in this line? We are calculating the step length. That's equal to delta x equal to minus eta dou f by dou x calculation. So that's what I am doing here. So delta x equal to minus eta, that's equal to 0.01 into gradient of x means it is a dou f by dou x, right? F of x equal to 2x square plus 5. So dou f by dou x equal to 2x. So that's the gradient, right? Now what is happening here is eta equal to 0, delta x equal to minus eta, that's equal to 0.01 into gradient of, suppose x, let us assume randomly generated value equal to some 2. Then what happened? Gradient of 2. So gradient of 2 means what it will return? 2 into 2, 4. So it will return 4. Now minus 0.01 into 4, that's equal to minus 0.04. Delta x equal to minus 0.04. So what else? What next we have to do? What next we have to do? We have to update your point. We have to update our point. right? So that's equal to x plus delta x. So initial point something 2, let us assume 2 minus is then minus 0.04, then x will be updated. So this process will be repeated until you are reaching the maximum number of iterations. Once it reaches the maximum number of iterations, then it will coming out of for loop. Now it will print optimal point of x, and also it will print what is the objective function value. So objective function value ఏంటి చూసారా ఇక్కడ empty, there are called math function here, empty dot POW power of x comma 2, this means x square, is called x square plus 5, this is called x square plus 5, right? Suppose if you want to write x power 5, what we are doing, just replace 2 with 5, it will give x to the power of 5. How we are writing the power, I think you can understand, right, in the Python. In case of MATLAB, you can write x hat 5, but here you have to write empty dot POW x comma 2, that is called x square plus 5. We are calculating the objective function, right? So now I want to run each one individual step here. Now I run here. In Google Colab, you can do a complex machine learning algorithm. You can't run complex machine learning algorithm because it will be restarted for every 1 hour sometime. If your algorithm runs over at hours of time, then it's not suitable. Yeah. Now run the second shell also. Now third one, iterative algorithm. Now I am running. It is the loop will be executed for the 10,000 times, and finally, so we know, right? So what is the minimum value of this function f of x equal x square plus 5? Already we discussed it. At x equal to 0, we will get the minimum value that's equal to 5, right? So you can find here. So objective function equal to 5, and x value equal to 1.7 into 10 to the power of minus 7. That means 0.000007, 1. That means almost 0. So you are getting at x equal to 0, you are getting the objective function equal to 5. Hope you understand, right? Similarly, you can find the global minimum point and the value for the function f of x equal to x to the power of 4 plus 3x square, right? Now only see, if you observe, piece of code is same here and here. But what the change you can observe here is only gradient will change, right? In the previous case, gradient equal to x, but here the gradient equal to 4x cube plus 6x. 4x cube plus 6x. Only gradient changes, and remaining all are same. So you can run here, and also here. Same piece of code, only gradient will changes because your object function changes. Now I am running this algorithm for the 10,000 times. What happened? Del x equal to minus eta. What? Why it is giving error? Because not remember. Empty dot y. Right. Perfect. Right. So see. We know by seeing this one, we can see that f of x equal to x to the power 4 plus 3x square plus 10. So you will get the minimum value at x equal to 0 and the value equal to 10. So that same thing is coming here. So objective function value equal to 10, and the x value equal to minus 2 into 10 power minus 269, and then almost equal to 0, right? So third exercise, it is somewhat different when compared to the previous one. Till now we are considered an objective function which contains only one decision variable, that's called x. But now I am considering an objective function having the two decision variables. So what the thing here is, you have to find the gradient of an objective function with respect to each decision variable. Right? That means what you have to do. Now our objective function is f of x y equal to 3x square plus 5y square plus 10. Let's assume initial points are x equal to and y equal to 3. Now what we are doing is you have to calculate the gradient of this function with respect to x, gradient of this function with respect to y at this point. Then what happened? Dou f by dou x dou f by dou x equal to 6x. This is the 0 and this is the 0. 6x. So 6x means 2. So 6 into 2, that's equal to 12. And similarly, you have to find the gradient of the function with respect to second decimal variable also. So dou f by dou y, that's equal to 10y, where y equal to 3, that's equal to 30. Right? So initially, if you have only one decimal variable, you have to find the only one gradient. If you have the two decimal variable, you have to do the two gradients you have to calculate with respect to each decimal variable. And later you have to update both points x and y. You have to update the both points. So if you want to update the both points, then you have to find delta x and delta y also. So delta x equal to minus eta dou f by dou x, that's equal to 12. Similarly, delta y equal to minus eta dou f by dou y, that's equal to 30. So we are calculating delta x and delta y. Now you are updating your x. So x equal to x plus delta x. So x equal to x into 2 plus delta x minus 1.12. So minus 0.12 is 1.88. Similarly, y equal to y plus delta y. So y equal to 3, initial value equal to 3 plus delta y, that's equal to minus 0.3, that's equal to 2.7. So this procedure will be repeated until number of iterations what you decided. Now for the same exercise, I have written a Python code. What else? What the new thing coming here is we have to random initialize the point for the two variables x and y, because we have the two decimal variables, right? So we have to initialize the decimal variable initial value for the two decimal variables, both decimal variables. Now this thing, right? Now you have to return two gradients. You have to, so I am executing here. You have to return two gradients. So what the gradient of the function with respect to x, what the gradient of the function with respect to y? With respect to x, that is the 6x. With respect to y, that's a 10y. So that two values will be written here, 6x and 10y. Right? So now same for iterating magma iterations. Now here we have to calculate the delta x and delta y. That's equal to, how we get the delta x and delta y? I'm taking small variation. I'm taking the only gradient. Now what I am doing, x equal to x minus eta into this gradient, y equal to y minus eta into y gradient. Same procedure will be repeated. Same procedure will be repeated. Right? I hope you understand. So all the links are available with you. Just sign in with your Google Gmail account what you have registered, and try to complete this Google Colab. And if you have any issues, so please let me know. I will be in touch with you up to 9 p.m. If you are interested, you can continue, or if you are not interested, you can leave the session. Right? But I am available up to 9 o'clock. If you practice and if you want to have any doubts, then please let me know. I will try to solve. If you have no interest and if you want to do sometime later, then simply you can leave the meeting. And thank you for your active participation for today. And tomorrow we will discuss about stochastic gradient algorithm and how it will help for the machine learning model by taking the one application. Yeah, thank you.
Sir, one small doubt, sir.
Please.
Sir, actually, while selecting the step rate, we have taken minus theta into gradient, sir.
Right.
So that negative sign is because of if our slope is positive, we have taken that negative.
We are trying to move the point toward the negative slope side.
Yes, sir. But while writing the program, we don't know whether the slope is positive or negative, sir.
We don't know. That's why I'm taking the minus sign, right? If it is a negative, then minus into minus, it will become positive.
Okay.
If it is a positive, minus into positive, that will be negative. That's why I'm taking negative.
Okay.
Yeah.
Okay.
Okay, fine. Thank you.
Okay, thank you, sir.
Hello? Yeah, that is maximum number of iterations So, hello, are you able to hear right? So, maximum number of iterations, we have to pick some value, large value. Coming to the your machine learning algorithm, if your accuracy is very low, then you have to increase the, that means that the training is not sufficient, then you may increase the number of iterations, right? So there is no criteria how many number of iterations you have to choose. You have to choose with some large number of iterations and you have to run the algorithm, because generally these algorithms are used in the machine learning and also used during the training process, and training is done in the offline, so you can ample of time. So how much time it takes is not an issue, but you have to train the model properly. So if the model is trained properly, means you are getting the good accuracy. If you are not satisfied with the accuracy, then you have to train again, and you can increase the number of iterations or you can change the learning rate. So these are the parameters, you can tune it until you are achieving the accuracy. So try to run that code, and especially programming point of view, as I told, it's like a ocean. Many things are available. As of my knowledge, even when I was working in a software organization, then also even though I was trained at that time on .NET and everything, if some new requirement is there, again I am depending upon the online resources. So actually it is not an exam, right? So we have to explore ourselves, and we have to explore ourselves, and we have to get the new things so that we can fulfill our requirement. As of my knowledge, I'm not sure whether this statement is right or not. No one is perfect in all the aspects. Suppose if I said I'm good in MATLAB, there are many things which I don't know. If such type of situation comes, then I have to learn myself by consulting some experts or by depends on the online. Svetama.
Hello, sir.
Hello.
Sir, actually, in the program, sir, in the gradient step, we are writing the function after taking the differentiation.
Right.
But instead of that,
Definitely.
is there any mathematical command for in Python to do automatically the differentiation?
Raghu, I don't tell that's not available. Maybe available, but I am not sure about that function. So I will explore and let you know.
Yes, sir.
Right? So
Yes, sir.
I will explore and let you know how we can find the gradient directly by passing the equation.
Yes, sir. ఇప్పుడు మనం తీసుకున్న ఫంక్షన్ కి మనమే డెరివేటివ్ తీసుకొని మనం ఈక్వేషన్ రాస్తాం కదా సార్.
Right.
అది దానికి
అర్థమైంది, మీరు చెప్పింది అర్థమైంది. I will try to explore. I can't say it's not available. Everything is available. So I will explore and let you know.
థ్యాంక్ యూ సార్.
So if you want to do the practice, you can do the practice. If you want to leave, you can leave, no issue.